Hello, everyone, and welcome to this new webinar. So today we would like to update you about the latest news and the latest software that we released end of November, so last month, mainly focusing on ntopng and the companion tools like the probes, nProbe, Cento, and nDPI, which is the deep packet inspection library that we maintain. We also want to take the opportunity at the end to discuss a little bit about the roadmap and ideas for the new year. So last month we released a bunch of softwares from actually almost all the softwares in our suites. We released ntopng 6.6, nProbe 11, Cento 2.4, nDPI 5, PFering 9.2, nScrub 1.8. As I said, in this webinar, we will focus mainly on the network monitoring tools like ntopng, nProbe, Cento, and nDPI. We also released the packet capture framework and nScrub, which is our DDS mitigator. What you see here, it's what I call our ecosystem. In fact, with our software suite, we try to provide 360 degrees visibility by providing both mainly passive monitoring, so packet capture, net flow collection, but also active monitoring with some sort of like speed test and stuff like that, also device discovery and stuff like that. But we also have inline tools able to, for instance, stop DDS attacks, which is the case of nScrub, or also layer 7 application firewalls like an edge and a new one that we're going to introduce, which is mFirewall. So in this webinar, we focus on ntopng that you see in this picture, which is our, let's say, collector, traffic analyzer, visualizer that has a web interface, as most of you probably already know, able to analyze the traffic and let you dig into the traffic and also export alerts with notifications, etc. So we will focus on this component, but also on related components like the sensors again, nProbe Cento, the deep packet inspection tool. So let's start with nProbe 11. In this release, we didn't have really big features, but we mainly consolidated existing features to make them more readable. But we also added a few small interesting features. For instance, we enhanced the TCP analysis with the ability, for instance, to export more information about the TCP flags. For instance, I don't know, the number of times we've seen a scene for a specific flow or other flags, which is interesting in tracking the state of a flow and detecting if this is, I don't know, a flood attack or a flow which is misbehaving. We also improved the mobile traffic analysis, for instance, improving the GTP, GTPC, GTPU correlation. In this case, we use the tunnel ID to match the, to see who is the IMCI behind a data flow, for instance. We also improved the detection, the dissection itself of mobile traffic, for instance, for fragmented traffic, or in case of complex encapsulations, if you have, for instance, a mix of GTP, GRE, MPLS, and other encapsulations. We also improved the swapping logic and heuristics. This means that in case we don't see a flow from the very beginning, or in all the cases where it's not simple to see who is to detect who is the client and who is the server, we apply some heuristics, and we improved this as well. And then we also extended the number of exporters a single probe is able to support, net flow exporters. But let's move to Cento 2.4, which is where the probe where we added more features in this release. First of all, Cento used to be a probe with a fixed template, so was able to export a fixed number of information elements. We introduced already in the previous release the ability to export information elements with a dynamic template, but this was applying only to Avro over Kafka. In this release, we had the ability to export a dynamic, a custom template also for when exporting JSON flows over ZRMQ, or the same for binary flows like TLV over ZRMQ or Kafka, or even when exporting those flows to disk in CSV or text format. So now you can choose which information elements you want to export. So which information contained in the flows, which metadata to export to ntopng or to a big data system or to file. Also in nProbe Cento, we added the ability to export more information about, for instance, TCP flags. We extended also in nProbe Cento the GTP analysis, supporting more encapsulations, and also here adding the correlation of GTPC, GTPU. Usually in this case, GTPC is processed by nProbe, the nProbe Pro Enterprise, which is exporting information using a cache to nProbe Cento, which is doing the correlation with the data traffic. And then we also added the ability in nProbe Cento to export statistics which are useful to monitor nProbe Cento itself, especially if you don't use ntopng and you have many probes, Cento probes distributed across the network, and you want to monitor the health of those probes or check how much traffic they are processing. Now you can use specific topics on Kafka or specific endpoints on ZRMQ to get the statistics. As I said, with this release, we introduced the ability to customize the templates, and we also wanted to extend the information elements supported by Cento that Cento is able to export in order to match those which are exported by default by nProbe, in order to provide full compatibility between nProbe and nProbe Cento, so that when you collect your data from ntopng, it's completely transparent. nProbe obviously exports much more information elements with respect to nProbe Cento. nProbe is able to run usually at 10 to 20 gigabit per second because it's really feature rich, while nProbe Cento has to be lightweight because, as you probably know, nProbe Cento can be used to process traffic up to 100 gigabit or more. So, of course, the number of information elements supported by nProbe Cento is lower, but with this release, we are able at least to export with nProbe Cento the same information elements that nProbe is exporting by default. Okay, let's talk also about the offloads. In the previous release, we already introduced the ability to use the flow table offload. That means that we can use adapters like NAPATech FPGA, which is implementing what they call the flow manager, to offload the flow processing in hardware, in the adapter itself. This was already introduced in the previous release and working nice, but in this release, we consolidated this offload, we improved it, and we also added the ability to export what we call the flow slices, which are the interim updates. So for instance, if you have a long flows, which is lasting minutes or more, with the previous release, you had to wait the end of the flow to get the counters updates. With this release, we are able to export interim updates so that your traffic, when you collect it in ntopng, for instance, it's more, it looks more real time because you see periodic updates. Now, as you probably know, nProbe Cento can scale up to 100 gigabit or more, and this is implemented by means of multiple threads that where you can load balance the traffic from the network adapter to multiple threads, or you can even capture traffic from multiple network adapters and process this traffic with multiple threads. Now, nProbe Cento used to process this traffic, again, with multiple threads, but then aggregate all the exported flows to a single ZRMQ endpoint for delivering to the collector like ntopng. Or another option was to aggregate those flows and then load balance them to multiple ZRMQ endpoints. Now, with this release, we also introduced what we call the direct mode for ZRMQ. That means that if you have, I don't know, 10 adapters, or if you load balance traffic to 10 streams using a single adapter, so you run 10 threads in Cento, now you can process the traffic for each stream and send the flows, export the flows for each stream to dedicated ZRMQ endpoint. This to provide full scalability. And of course, in ntopng, you have to process all those streams using multiple ZRMQ endpoints and aggregate them, the information in ntopng. Let me show you an example. In this example, we have nProbe Cento analyzing our 1 gigabit link with an Apatec adapter providing flow table offload. So the adapter is doing most of the processing. Then we are also using what they call streams, which is in practice RSS, receive side scaling, to distribute the load and deliver packets and flows to multiple streams in nProbe Cento, in this case 12 streams. Out of those 12 streams, we use the direct ZRMQ to send the flow information to ntopng using 12 ZRMQ endpoints. So what you can see on the left side of this slide is one chart per ZRMQ endpoint where we see the number of flows, the traffic over time. And in the middle of the screen, you see one of those streams. So you see that each of these streams is processing a few gigabits per second. And then you can use the view interface to aggregate all this traffic in a single view. And in this picture, we can see a chart where we have a combination of all the ZRMQ endpoints, where each endpoint is delivering a subset of the exported flows, and the total amount of flows here, concurrent flows, is more than 20 million flows. This is a stacked chart that we have in ntopng. So this to say that with the very latest features, we are able to combine hardware offload streams using this specialized adapter, but also with a standard adapter like Intel or NVIDIA Mellanox adapters. We can do the same, but without the offload, of course. So we can still use the load balancing and combine these with the direct ZRMQ feature to deliver multiple stream of data to ntopng and aggregate it. Okay, now my colleague Matteo show you what are the new features that we introduced in ntopng 6.6. Thank you.
So now let's talk about the latest ntopng version and the news we have about the ntopng 6.6 version. Now, what we tried to achieve with this latest ntopng release is, simply speaking, improving performances, improving features we already had in ntopng. So we tried to improve the whole, I'd say, ntopng. Now, let's start by talking SNMP. Previously, I'd say even from the 6.4 version, so the previous one, we had a problem. We had a problem with the upper limits of the possible devices we could poll. Why do we have this problem? Simply because nowadays the networks, even a medium-sized network, have more and more small devices, more and more devices, which is routers, whatever. And this brings up a problem. This brings simply the problem that with the increasing of these small devices inside the network, it is still more difficult, I'd say, to power every single device in time. Also, with the increasing number of devices inside the network, what does it also increase? It also increase the number of interfaces. Simply speaking, even in a small network, we could have hundreds or even 1,000 of interfaces. And this brings a problem, a simple problem, I'd say. The problem of recognizing each single interface role, I'd say. So, for example, we have a switch. A switch has a port that brings the traffic inside your LAN and the port that brings the traffic towards your router. Simple example. But with the increasing amount of interfaces and devices, this problem escalates. Now, we try to improve, I'd say highly improve the performances of SNMP with trying to address this problem of the increasing number of devices. And we are happy to tell you that we really improved the SNMP and we are now able to power up to more or less 500 devices. Also, you have to consider that in ntopng, the power of devices by using SNMP is done every 5 minutes. This means that we are now able to power up to 500 SNMP devices every 5 minutes. Also, what we improved in the SNMP aspect is the caching of the data. The caching done by obviously ntopng itself. But this brings up new improvements. Simply even talking about the web interface, the ntopng web interface, whenever you see an SNMP interface or SNMP device name shown on the web interface, that is done by getting the data from the cache, from the ntopng cache. Optimizing that caching and the names lookup, this means that we also enhanced vastly, I'd say, the performances of the web interface. Also, like I was saying, we try to address the problem of the increasing number of interfaces by adding the possibility to tag, to label an interface with a role. For example, an internet exchange interface, an internal LAN interface, and we added those tags, those roles inside the ntopng web interface, hoping to enhance the navigation inside the ntopng itself. Also, in the 6.4 version of ntopng, we added the concept of assets. So all the local devices that are inside your network, and they are really important because obviously with the increasing amount of devices inside the network, it is important, really important, to know what's inside your network. And so we thought, we have SNMP in ntopng. And SNMP, we also support the bridge MIB, the SNMP bridge MIB. The SNMP bridge MIB provides the MAC addresses of all the devices that talk inside a network. So why do not integrate the SNMP features inside the assets? So we decided to add the SNMP bridge MIB information inside the assets In this way, it is also possible to see each single MAC address that worked inside the network by also combining the SNMP bridge MIB information with the ntopng information we have. So we are now able to say that we have seen a MAC address, for example, in the first row AC, etc., with the IP 2.97. The last time was seen on that data, so pretty much an hour and a half ago, on the switch procurve on port 21. In this way, we are also able to now point exactly the last time a device was seen inside in a network with which IP and on which switch or router or device was seen. Now, still talking about improving. We decided to also improve the flow exporters. We also enhanced the flow exporters with various information. Sometimes it is important, in fact, to answer simple question like who's exporting a lot of traffic? Is the interface okay or not? So we developed a new page in which you see every information of every single device and interface and the amount of data exported, the role it has, etc. But also, sometimes it is also important to answer more difficult questions, I'd say. So, for example, from which switch router interface is the flow is flowing the traffic, or do we have a transit or not? Well, we were also able with this latest release to grab, let's say, those information from the flows and display them in a new page. In a new page, for example, where you can see the source autonomous system from which transit autonomous system passed, into which exporter, and where it went. So in this way, mapping the exact flow of the flow so from the source to the destination, passing from where. Now, like I was telling you, we tried to enhance the performances, and this brings also the performances of flow exporters. In fact, flow exporters were a bit lacking when receiving the data, the information from nProbe. Also, we had quite a lot of, not quite a lot, but we had quite a few drops when talking between probes and ntopng. Now we optimized all those statistics, all those data structures, all those parsing to have a lot better performances. Not only we tried to improve the performances from the SNMP or flow exporter side, but we also decided to improve the performances from the database side. In fact, what you have to think is that before this release, we had, I'd say, some problem with ClickHouse. Because yes, ClickHouse is really, really fast. I think I'd say one of the best databases out there for now. But it has some problem. It has some problem, obviously, when talking about really a lot of data to put into. And we had the problem with the development we have with ClickHouse, because pages were too slow, even if we were talking about filtering, searching inside of millions and millions, if not billions of data. And if we compare those time with other databases, they were really quite good. But still, we were not happy about those performances. So we decided to improve the performances from the ClickHouse point of view by adding the support of a native C++ library, of the native ClickHouse C++ library. And that brought huge performances boost for queries. First of all, because it supports native data type in queries. For example, the IPv4 or IPv6. Those are data that are supported by ClickHouse, and previously we were not able to use that feature of ClickHouse due to the fact that we didn't have the native C++ library. Also, that brought simplified queries because supporting the native data types helps a lot. And also, with this new support, we also decided to change, to optimize many queries. And that brought a huge boost in performances. In fact, we can say that from lesser than 100K flow per second, now we are able to support up to 300 plus K flow per second. And also, we are damping the flows directly from the C++ library, not passing through a CSV, not passing through file system. That brings also, I'd say, less stress on the machine itself. Also, we decided to add the direct flow dump into ClickHouse, to our ntopng with ClickHouse. What does it mean? It means simply better scalability, near instance availability for queries, and that is simple because instead of receiving a flow, processing and enriching the data, and then when the flow expired or after passing an exact amount of time, the flow is dumped into the database. Now, instead, if the direct flow dump feature is enabled, that flow, when received, is immediately dumped into the database. And this helps a lot with searching the data and also with scalability. About ClickHouse, we also now have the native support for ClickHouse Cloud with SSL connections. So you can now also connect to your ClickHouse Cloud. And we have many more improvements that just to give you a small summary, we increased, for example, the host pools number. Now we are able to have up to 596 host pools. Also, we really improved the Redis operations, again, by optimizing the caching. This brought a lot of, obviously, improvements from a faster web interface, because, like I was saying, every name is taken by Redis by using a cache. Also, faster periodic activities, faster REST API. And however, we did not also only enhance the backend, I'd say. We also developed a lot of new pages, reworked a lot of new pages. For example, one new page I wanted to introduce is the alert graph. The alert graph is, simply put, a new way to display alerts, a new way to understand faster who is the problem inside the network, who is bringing thousands of problems inside the network. And we needed a way, obviously, to detect, I wouldn't say instantly, but as fast as possible, the problem inside the network. So the layers graph is a new way to see the problems inside the ntopng by searching for the hosts that are bringing the problem. For example, you have a map where the darker the color of an host is, the more problem it has. Also, you can say instantly that, for example, the 2.97 is the main problem inside this network. It is or creating a lot of problems or receiving a lot of problems. So it is a new way to find and respond to the problems inside by aggregating the alerts. Obviously, we have many more changes regarding the web interface. We migrated a lot, really a lot of pages to the Vue.js framework. This brings faster loading, more responsiveness, and also hopefully in next year or soon we are able to divide the client and server side to bring a lot more performances changes. I leave Luca talk and continue about the autonomous systems.
Hello, good afternoon. Let's now talk about a brand new feature that we have introduced in ntopng. For a very long time, we have managed to analyze network traffic using flows or packets, but we didn't go too much into the information provided by the flows. So therefore, we have decided to fill this gap. When we talk about traffic and flows, we think about autonomous systems because the traffic in the internet is moving from one autonomous system to another. And in this case, we need to understand not just the packet content, so IP address, port, protocols, and so on, but also the trajectory that the packet has taken to reach us or from us to the internet. When we talk about autonomous systems, we are not talking just about an internet provider, but also many large companies have an autonomous system, and they need to understand how the traffic moves inside the company itself. For this reason, we have introduced a new feature called AS traffic monitoring. For this type of analysis, the source is only flows. So because the flows contain information about the packet trajectory and about the packet routing. Instead, when we look at packets, we can only see the packet content, but we don't know exactly where the packet originated, where the packet is going to. And in addition to this, we have decided, and this is planned in one of the next releases, to add more information about routing. For this, we need probably to talk with routers using a protocol called BGP. And this is part of a future evolution of the product. So today I'm going to talk about what is existing in ntopng. Let's first give you a quick overview of what is inside the flow. When a router is delivering you a flow, it does not only contain information about bytes and packets, but it also contains information about the network interface from which the flows has been received and is sent out, and also information about routing and peering. So that says this packet has arrived from interface X that is used to talk with next hop Y, and also from the autonomous system Z. This is very important because we can also characterize the traffic. But this information is available in flows only when they are exported by a router that knows a little bit about internet routing. Probably is not the case for most of you, but I believe that a big portion of you have routers that know the internet table, or at least a part of the internet table, at least until the next hop. Inside this flow, we have this information that is sent from the router to nProbe and from nProbe to ntopng. Note that we are still able to do deep packet inspection, but this DPI it is limited because it can only use IP addresses and ports. It cannot go deep into the packet. So the P in DPI it does not hold anymore because we don't have the packet, but we have the flows. And also note that when you have packets, you can still use packets with AS mode, but you will not be able to see the information that I'm going to describe you now because it's simply not present. In ASN mode, also you have the ability of specifying inside nProbe a new flag called ASN mode that allows you to hide the IP addresses from the flow. This means that you will masquerade the last part of the IP address according to the network mask that is inside the flow, so that you cannot understand if a certain packet has been originated by one host or another, but you know only the network. This is an optional feature that you can enable or disable. You can disable, don't use this flag if you want to have full visibility as it is today, or if for privacy reasons you don't want to know the exact host that is doing a certain traffic, you can implement this, so simply adding this flag to nProbe. In order to enable ASN mode, the only thing you have to do, in addition to, of course, export the flows with ASN information, is to go inside the ntopng preferences, go to ASN mode and enable it. That's it. This will switch the user interface from the standard user interface you know to the ASN mode user interface. Inside this user interface, you also have the ability of configuring a few things. The most important one is your autonomous systems. So basically, we have created a new preferences inside the network configuration, okay, and that contains 3 items. First of all is my ASN. So you have to specify here the number so that correspond to your autonomous systems. It can be just one or a few. This is important to understand that this is the new concept of local traffic, because those autonomous systems represent the traffic that belongs to you. Then if you are an internet provider, you have some customers that rely on you, meaning that those customers are attached to the internet through you. So you can specify here the list of customers. If you are not an internet provider, but you're just a large company that has an edge router, simply leave this field empty. And then here you can add a list of other autonomous systems that are relevant for your company. For instance, Amazon, Cloudflare, Google, and so on. Those are important because you want to trace information about them. So you want to keep a history of them, okay? But they are not your autonomous system, but they are relevant for your business. In SNMP, as Matteo said before, we had some enhancements. One of the enhancements is to specify the type of port, okay, of a certain network interface. In the past, SNMP was flat, so every interface was equal. Now we have added the ability here, you specify the type of the internet interface. It allows you to specify, for instance, if this is a certain interface used for routing, for internal inside the LAN, or for connection to the internet. This is important because we can characterize the traffic. In ASN mode, we have a new dashboard in addition to the existing ones that allows you to see, based on the autonomous system configuration that you have done before, what is happening on your network. You will see here the top ASN, so basically the top AS that are used in your network according to the traffic. And for instance, the top Ethernet interfaces from which you're receiving traffic or you're sending traffic. As you can notice here, we have implemented a stacked, okay, as everywhere else in ntopng. That allows you to decide whether you want to see stacked graph or standard graphs. This way, you can immediately see what is happening on your network and where is your traffic going to. And you can go deep into the ASN mode, looking at what each individual ASN is doing. So we have introduced something called AS view. In this AS view, you will see here listed in the bottom of the page all the autonomous systems that are exchanging traffic with you. And at the top of the page, you will see the chart, a stacked chart of the traffic. It's possible to visualize the traffic in real time, so what is happening now or in the past. So you can specify here in this drop-down menu what do you want to see. Here on the actions menu, you can see various actions. So for instance, you can see what hosts are currently active on a certain ES or what flows. And so you can see in real time what is happening. So if you see a traffic spike on an ASN, you can immediately see what is happening in real time. And here we have added an icon that represents the type of autonomous system. So for instance, here we are filtering all ASN at the top of the page. But otherwise, you can see show me only my customers, just to see if your excess use of internet traffic, who is using this bandwidth, and try to understand the root cause of the problem. In addition to that, you have something called AS view. Inside the AS view, we have the ability of understanding for each AS, shown you in the previous page, what type of traffic a certain AS is doing. We are talking about routing traffic. So for instance, in this page, you will see that this autonomous system we are monitoring, this is the way it is receiving traffic. So most of the traffic is received by these two top AS from Facebook and Google, and is sending traffic towards various autonomous systems. Okay, and here at the bottom of the page, you will see a detailed view of the page, and of course with time series. So you can see over time, for instance, how your traffic is changing during the day or overall towards certain autonomous systems that are relevant for you. Similar to that, we can also visualize the traffic, how it is received, and what interfaces. So for instance, in this case, for this autonomous system, for received traffic, we see that this traffic has been received by this router or this router on those interfaces. And when it's sent out, most of the traffic is sent on these large interfaces, and the rest on these small ones. So just to give you an overview of the traffic, not in terms of AS, but in terms of interfaces. And of course, if you have a customer, again, this is probably not the case of everybody, but for ISPs, definitely, you can see how a certain AS is used by your customers. So you can see, for instance, Facebook, okay, what are the customers of your company, how much traffic is used by customer A or customer B for a given ASN. And you can here on this drop-down menu immediately see who is using the traffic. And of course, so we have the standard time series analysis with nDPI. Again, we cannot do P, meaning packet inspection, because we don't have packets, because here we need flows, but we can guess the protocol, at least for big guys, based on IP and port. So for instance, if I see the IP address of Office 365, nDPI knows that this is this traffic, okay, because it has been advertised by Microsoft. So in this case, we know exactly this AS365 traffic. Otherwise, we guess the protocol based, for example, on the port. If we see TCP port 80, we guess that this is going to be HTTP. But again, we are not sure 100% because of the lack of visibility in flow-based analysis. We have added also the ability of specifying something called traffic rules. So in this case, we can specify certain conditions that, if met, trigger an alert. So for instance, you can say, if I receive too much traffic on this interface of this router, trigger me an alert, because sometimes you're paying the traffic based on the bandwidth. Or you can say, if this AS is receiving or sending too much traffic, then trigger me an alert. Simple as this. You can see that we have extended the standard configuration for alerts, add a new entry called ASN. Okay, in this ASN, you will see here the list of autonomous systems. You can see the metric, usually the traffic Rx plus TX, and you are able to specify a threshold or specify a percentage. If the traffic now is more than 50% of the traffic of the last hour, then send me an alert, things like that. Alerts have been enhanced. We have added a new entry called AS. Okay, and here we specify the alerts that are relevant for the autonomous systems. So for instance, in this case, we have threshold crossed, because on the previous page here, we have added a traffic rule that says, trigger me an alert in case of something. And here you have the ability of understanding what is happening and what is the autonomous system that has triggered that alert. Inside the alert, you can see also the condition. So for instance, in this case, we have set a threshold of 400 megabit, and we are above it. And this is the condition. And this is specified how often we check the threshold. It is also possible to enable a new type of behavioral check that allows you to specify how a certain AS is reached. So for instance, if you're talking to Google, okay, on router A, port Y, and you're still talking to Google, but on another port of another router, so the ranking is changing, this one can trigger an alert. So this is an example. So let's focus on this AS, Disney, okay? So in order to go to Disney, to talk with Disney. In the past, this was the ranking, okay, the bottom one. So most of the traffic was passing from this interface, 18 gigabyte, and this interface, 1500 kilobyte. Now, this has changed to this interface, okay, so this new view. So in essence, if you see, you perceive that there is a change in the network, not because there is not reachability, but because the traffic is not coming from the existing interface, but is coming from another interface, probably because of routing changes. This is a perfect way of understanding that. So this can be used to explain, for instance, latency problems. So sometimes, especially for cloud-based services, you experience a different type of latency based on some traffic conditions, and this can give you a hint on why this has happened and how this can be resolved. Another important problem that we see is billing monitoring, because as I've said, there are some interfaces, router interfaces that are flat, so you pay a flat fee and that's it. For other interfaces, you pay a premium fee when your throughput exceeds for a certain period of time a certain threshold. So because of that, we have enhanced the SNMP monitoring that Matteo has described before. I'll show you how. In essence, here on every interface on SNMP, you will see that there's a usage, okay? There's usage percentage that is calculated based on the speed and on the interface type. Based on that, so we have added the ability of specifying threshold, because many times you have an Ethernet interface, let's say a 10 gigabit interface, but you're paying for 1 gigabit. So this means that when you exceed the 1 gigabit, the usage is above 100%. So you can specify here on the new preferences for the interface the ability of setting the threshold that for you means 100%, regardless of the interface speed. Based on that, it's possible to have a new entry here called usage under SNMP that displays you the congestion rate. So what interfaces are above a certain threshold, and when this happens, what are the interfaces that are most used. This is also interesting for capacity planning because you can understand over time what is happening on your network, and this can be probably an explanation of some performance issues you will notice looking at packets, okay? But can give you an idea of how to map this to an infrastructure and how to solve this problem. We have decided to add this ASN mode in all editions. The main difference is the following, that in the community edition, you can only see real time. So it means that you can monitor traffic in real time with no historical, because it is lacking the database support that is present on the enterprise edition. Other than that, basically there are no main differences. So it means that we want to create a new generation of open source software that allows you to monitor ASN traffic, okay, without using costly services, okay, that are very expensive. And of course, if you are educational research or no profit, all our software is free, as you know. We have plans for future enhancements because we have not completed what we have in mind. In particular, we want to integrate the BGP support, add further alerts. So for instance, DDoS alerts. Okay, this is something that we want to do because we would like to complement nScrub, that is packet-based, with this type of flow-based analysis. We also want to better visualize and understand the cost of internet exchange links, okay, or peering, transit. So we would like to improve the user interfaces for that. And then if you have other ideas, we'll be happy to hear you. Let's talk about the last topic very quickly so that we can let you ask your questions. nDPI. nDPI 5 is a major release where we have changed many things. The main changes of this release are new fingerprinting methods. The fingerprint is the ability of characterize traffic looking at the initial packet bytes. So we have created a new type of fingerprint called nDPI fingerprint that combines the TCP fingerprint. So for TCP-based traffic, this is very important. We can identify the operating system. That this is a feature that is now present in nDPI. So from the first packet, so from SYN, you can understand if this is a Windows machine or a macOS machine. We cannot go too deep. We cannot tell you if this is Windows 10 or Windows 11, but for sure we can say this is a Windows machine or an iPad or an Android phone. And then we have the industry standard JA4, and of course the certificate hash, so in case you want to put it part of the fingerprint. This fingerprint is useful because it allows us, you can read the blog for more information about that, to characterize something called VPNs that are not really VPNs, but are mostly on Android. They are available on the Play Store. Some application that allows you to circumvent security on networks, creating a sort of TLS-based or SSH-based VPNs. So this is very useful for tracking them. So look at the blog. You'll see some articles about this topic. We also had the ability of detecting hosts that don't use DNS for resolution. And this is very important for identifying anomalies, behaviors that are probably not too nice, or cover channels. We can also have the ability of defining many rules, because nDPI, we envisage it to become an engine on top of which users can create their own rules for simply just configuration for detecting new protocols. We have added the new protocols, and now we have over 450 protocols and 30 different categories. We have implemented the protocol stack, so the ability, for instance, going above the network application protocol, but to create a stack like this, so as many protocols as necessary, in this case 3. And also we have changed the API classification and introduced a new type of monitoring mode called nDPI state monitoring that allows you to monitor the traffic not just at the very beginning, as nDPI used to do, but over time. This paves the way, for instance, to opening nDPI to much more than the initial packet bytes, but to understand how the traffic changes over time. This is one of the few topics that we are implementing in nDPI 5.1. Basically, that's all. Okay, I just want to give you a quick overview of what we have in mind, but we would like to receive some feedback from you. So first of all, we would like to enhance ntopng to consolidate alerts much better and to make them simpler, because we acknowledge that sometimes they are hard to, it's hard to understand how they are delivered to a remote recipient, how to clusterize and characterize them. So this is something that we definitely are interested. So we have received some criticism about the way alerts are delivered to remote recipients, and this is what we are already working at. We also have in mind to replace the concept of view interface, where we are merging traffic into a single interface with a better interface aggregation. This is because sometimes with 100 gigabit links, we receive so many flows that the view interface is too slow. To merge this requirement with namely speed with visibility, and we are making some tests. We don't have a solution yet, but this is definitely a topic that we are developing. Another item is OT monitoring. As you know, for those that are using OT with ntopng, we're able to monitor IEC 104 and Modbus, okay? And we'll complement this with new protocols, okay, and new active probing. So it means that when you have, let's say, a Modbus device, we can go and query the device type, the firmware version, and other type of information. So we can enhance the assets categorization that Matteo has told you before. And we are planning to add a new protocol, S7 Profit UPC UA, and this will probably be part of the next release. This is the plan. We are still thinking about AI. AI is not a topic. We have made many experiments in the past. We didn't introduce anything yet because our feeling is that we should continue along the line that we started 25 years ago, meaning that if we add AI in our products, it must be lightweighted. It doesn't make any sense for you to require a super costly GPU with a lot of RAM, a lot of CPU for doing that. But we see that today there are many improvements on the market, and we are considering to introduce them into our products, especially for traffic classification and anomaly detection. We don't yet have a solution. We are not ready for prime time, and as soon as we have something available, we'll inform you. But if you have ideas on how to enhance that, it would be nice that you speak and tell us your feedback. The last thing, the first product that we'll announce next year will be nFirewall. That it's a layer 7 firewall designed for small users, of for OEMs, or for those who have Linux firewall or Linux box, and that we want to complement it with the layer 7 analysis for firewall, for preventing certain users from doing what, or for blocking cybersecurity threats based on that. Again, this is something for next year, but we're almost at the end of the year, so you don't have to wait too long. That's all. So I'm opening the stage to questions. If you have any, I will be happy to answer with my colleagues.